In the previous lecture, we were doing a question for JEST. I'm continuing from there only. So the question that was asked was that if this is integral 0 to 1 pmx pnx dx, and we want to find what all conditions would make this integral to be 0, given that m is not equal to n. Given that m is not equal to n, which of the following condition which of the following condition would imply that your integral would vanish? And integral is, mind you, not -1 to 1, it is 0 to 1 pmx pnx dx. So I was discussing it with one of our students, and so I and she, like, if I want to do, like, if I take m and n both even, if I take both m and n even, this was the first case that I was discussing with her only. Now the remaining ones I'm recording. So what I'll do, I'll take -1 to 1 pmx pnx dx. So I know if m and n are both equal, are both even and both are unequal, this would be 0. Is that clear? Now what I'll do, I'll use the property of integral. I'll take an integral from -1 to 0, and then plus 0 to this. And I know that my this is something that I already know, that pm minus x would be -1 raised to power n pnx. This is something that I already know. So this suggests that if n is even, then if n is even, then my Legendre's polynomial would be even function. If n is odd, then my Legendre's polynomial is an odd function. So in the first integral, this integral, if I replace x by -x, and given that m and n are both even, so this will be pm minus x will become pmx only, and this pn minus x will become pnx only. This dx will become minus dx, and this -1 will become 1. This will become 0. So instead of minus dx, write dx only, and then this is from 0 to 1. Like, you can revert the limits. So if you revert the limits and you add them up, you'll get 2 times integration 0 to 1 pmx pnx dx equal to 0, or you can write integration from 0 to 1 pm pn dx equal to 0, provided m and n are non-zero even integers, are non-zero, or in fact like even integers in general. So I'll write are even integers, and understand the fact that both of them are not equal. If both of them are not equal, and if m is even, n is even, subtract any of, like, m minus n. So what you'll get? So if m is even, n is even, their subtraction would also give you a non-zero even integer. Is that clear? It will give you a non-zero even integer. So if you subtract 2 even integers, you will get another even integer, right? Subtract 4 minus 2, subtract 6 minus 2, subtract 8 minus 2, subtract 8 minus 4, find 8 minus 4, find 10 minus 4. Whichever way you want to find, you will get a non-zero even integer. Is that clear or not? So this is something that you know. Now, the second case that I was thinking is, let us take m as odd and n as odd. If I take both of them odd, then this integral, the first integral, I can write pm, instead of x, I'm writing minus x. Instead of x, I'm writing minus x. So here you will get minus dx, here you will get 1, here you will get 0, plus integration from 0 to 1, and you have pmx, you have pnx, you have dx. And if I write that way, and so what it will be, so this minus dx you take common out. So this is from 0 to 1. And I already know that if m is odd, then pm minus x would be equals to minus pmx, and pn minus x would be equals to minus pnx. So if I multiply both of them, what I'll get, I'll simply get pmx pnx only. So my pm minus x, pn minus x would be equals to this. So I'll write 0 to 1 pmx, and I'll write pnx, and I'll write dx. I'll write integration from 0 to 1 pmx, I'll write pnx dx. This is equivalent to writing 0 to 1 pmx pnx dx. And understand, if m is odd and n is odd and both of them are not equal, then this particular integral would become 0. So this particular integral becomes 0, matlab ye is 0, and it implies this is 0. So again, I'll write that integration from 0 to 1 pm pn dx would be 0 if m is odd and n is odd. And if both of them are odd, then their difference would be even always. You can take that in this fashion also. Let's say if m is odd, I can express m as 2k1 plus 1, where k1 is any natural number, or you can say including 0 as well. And if n is odd, you can write it as 2k2 plus 1, where k2 also belongs to any such natural number within 0. So if you take a difference of m minus n, you'll get 2 times of k1 minus k2, 2 times of anything, again even. So in any case, if m is even, if m is odd, n is odd, so their difference would come out as an even integer. Is that clear? Okay, so let us see the options. So one of the most possible option that I see from here is m minus n must be an even integer. M minus n must be an even integer. Now, this is what I think. Like, this is what I think is a right option. Now, what if m minus n is an odd integer? So this is something that we've already proven. This is something that we've already proven. Now, what you can take? Now you can take some values to reject other options. So if m is odd and n is even. So if m is odd and n is even, for example, let us take m equal to 1 and n equals to 2. So their difference would come out as, so their difference, or you should take, ऐसा कर लेते हैं, m is even ले लेते हैं and n को odd ले लेते हैं. ठीक है? So let us take n to be odd and m to be even. So if I take this, what I'll get? 0 to 1. What was your pmx? Instead of pmx, you will get p2x, and pnx you will write simply this. So this will be 0 to 1. This is x into 3x square minus 1 upon 2 dx. And eventually you'll get simply 3x cube. So 3x cube is 3x की power 4 upon 4 minus this x upon 2, you'll get x square upon 4. So this is x cube. X cube is 3 plus 1, that is 4 upon, I think this will be 8, I guess. Okay. And from 0 to 1. So if you write 1 here, so this is 3 by 8 minus 1 by 4. So this is equivalent to writing 3 by 8 minus 1 by 4. So you take 8 common out, you'll get 3 minus, and this will be, I think, 2 only. So this is 1 over 8. Certainly it is non-zero. Certainly non-zero. So if you want to find, I think there's some mistake or what? I don't think there's a mistake. Again, let us see. So this is x cube, 3x cube. So 3x cube, when I 1 upon 2 bahar le lo, 3x cube, if I integrate, I'll get 3x की power 4 upon 4 minus x का integration क्या था? X square. Right. So we are right, I guess. So in any case, understand this is non-zero. So this will, this is one of the options. So what does question say? Question says which of the following condition always suggest that your this particular integral would be 0. So if I take m to be 2, n to be equal to 1, then m minus n would be an odd integer, but the integration is a non-zero integration. I'll write here, take m equals to 2 and n equals to 1. So you can reject using that. For all m, no. Why for all m? Just take, for example, all m not equal to n. So for all m not equal to m. So let us see that also. And the last option says that if you take n equal to m plus minus 1. So if you take n equals to m plus minus 1, so that also we'll have to see. So 2 options is for all m. For all m, m not equal to n. So let us think about it. Again, take for all m, take m equal to 2 and n equal to 1. So this again, all m, it is saying that for all m it is true that this integral would go to 0. No, take m equal to 2 and n equal to 1. So m is not equal to n. And if it is true for all m, then it should be true for m equal to 2 also. So this integral is coming out as 1 over 8. This integral will also come out as 1. So you cannot take these two integrations. And also, if m is equal to 2 and n equal to 1, so if m equal to 2 and n equals to 1, then if m is equal to 2 and if this is the case, then n equals to either 1 or 3. So if you take n equals to 1 also, like if you take just one sign, that is, if you take minus 1 also, then also it is not true. So again, this will be rejected. Since if you take n equal to 1, if you take m equal to 2, sorry, if you take m equal to 2 and you just take this negative sign, the 2 minus 1 is what? 1. So n equal to 1. So if you take m equal to 2 and n equal to 1, this will satisfy, no doubt, this particular option. But we know that integration p2, p1 integration is coming out as 1 over it. So certainly this is also not true. So in any case, option number C will be the correct option. So option number C will be the correct option. I hope it is clear. This is quite clear to you. So this was asked in JEST exam, and certainly we are going to do a few more questions as we go along. Till then, take care.